All right, welcome everybody. We are going to be looking at gears tonight. So let's take this moment to do some review of how we do gears. So if you look, we're in Fusion. First thing we want to do in our workflow is we want to save this. We'll call this gear test 2. You can call it simple gear train if you want, something along those lines. And we're going to make some gears. So we go into the utilities tab, go under the add-ins, scripts and add-ins section right here. And then if you scroll all the way at the bottom, you'll see the spur gear. And now we are going to create a spur gear. Um, and typically the diametral pitch that we're going to use for wood is 8. And if you look at the number of teeth of 24, you can see that our root fillet radius here is this 0.063. We want to make sure that this is greater than the radius of our bit that we're using to cut. So right now, this is basically a 16th radius, which would be an 1/8 inch end mill. So we're going to be using an 1/8 inch end mill, but we want to be a little bit bigger than that. So we're going to go 130 thou. So 5 thousandths over the 125, which is what that would be, and then divide by 2. So we're going to do 0.13 divided by 2 for that root fillet radius. And then our thickness of our gear is going to be 0.125. The whole size on that is going to be 0.2. And our backlash, we are going to put 5 thousandths for our backlash. This gives us a little bit of gap in our teeth when we put these two gears together. So we're going to say okay, and that's going to give us a 3-inch gear. We're going to get two 2-inch gears. We're going to make like we're going to make a little, basically 4-wheel drive type setup for best robotics. So typically we'll have this gear on our main motor, and then it's driving 2 smaller gears that are attached to our wheels, which then allow us to have 4-wheel drive for our robot that we make. So we're going to do add in again. Same thing, go down to the spur gear. Should keep our settings from before, so the only thing we have to change is the number of teeth. So if we go to 16, that's going to give us 2. So if you take the number of teeth and divide by the diametral pitch, it gives you the pitch diameter on that. Then we can hit OK. And there's a 2-inch gear. And then we're just going to copy and paste that. So copy it, go up here, paste. You can move it if you want. I'm just going to say OK. So now we have 3 gears. You can see the 3 gears that we have. And we're essentially going to move them so that this one is kind of sitting right in here. And then this one's going to be sitting on the other side, kind of like right here. Is what we're going to do. So we're going to make this pattern on a backer board that we can then attach our bolts through. So that's kind of the general shape that we're going to get at as we do this. So let's make our backer board. So we're going to right click new component, and we're going to turn all these off. And then we're going to just go to our ISO view, go back to solid, and create a new sketch on this sidewall. Revert position just takes all those gears and stacks them back on top of each other like they were originally. So imagine this being the side of our robot. Okay, so we're going to have a spot where one of the gears is going to be here, one of the holes is going to be here, and then we're going to have a hole up here. And again, that would be attached to a motor shaft going through, and then attaching these gears is essentially what we're going to have kind of set up here. Can I go ahead and dimension these? I'm just putting some arbitrary dimensions on this. I'm going to make this 6 inches, make this 4 inches tall. And then I'm going to go ahead and put some points. Put point here, point there. I'm going to geometrically constrain these two so they're horizontal to each other. I'm going to dimension these two. And this is going to be the dimensions between the centers of my 3-inch gear and my 2-inch gear. So if you think about the radii, I've got a 1.5-inch radius for the 3-inch and a 1-inch radius for the 2-inch for those to touch. So this has to be 2.5 inches for that. I'm going to do the exact same thing for this one. It's going to be the same 2.5-inch distance. But now you can see that if you grab this center point, like it could be anywhere from 5 inches apart and as close to about here. You just don't want those 2 gears to touch. I'll kind of simulate what this looks like. So you're going to have a gear here, a gear here, and a gear here, right? So this one's going to be a 3-inch diameter, and then this one's going to be a 2-inch diameter, and we're going to say that this one is equal to this. So you can see this is what it's going to look like in space with your gears. And as you move this, like you can see how if you move this closer together, these gears can't touch with their teeth. So this is too close. So this is about as close as they're going to be, and then as far as you can be is along there. But again, typically you spread them out like this. We could set the distance between these two, and this is going to be our wheelbase distance. And I'm going to say this is 4.5 inches. That's a good distance. You don't want this to be straight across because then sometimes this gear gets in the way of ground clearance and so forth with your wheels. But this is good. I can move this now to center it. I can then do some lines that are construction lines from the midpoint down to this midpoint. I can constrain this right here to the midpoint. So now it's locked into there. Now I can go up and down. And again, you can see that if you had wheels on this, you could put a set of wheels, maybe like some 3-inch diameter wheels on this. Let's just pretend. So if you put a 3-inch wheel on here and a 3-inch wheel on this, kind of see what that's going to look like. There's a 3-inch. Those would be like the side view of your robot. You can see the ground clearance. You could even calculate the ground clearance on this. So if you found a line between these 2 points, you can see its tangent. And then you can say, okay, what does the ground clearance need to be between here and here? You can say, well, can I make that 1 inch? This one has to be tangent, so I need to move to this point so it's tangent. This dimension's messed up. So I delete that. Tangent, this to this. There we go. And now we should be able to do a dimension between here and here and give us like a 1-inch ground clearance. So now we know exactly where those holes need to be for those axles so that we have our gears here, our 3-inch gear, our 2-inch gears. We've got a 4.5-inch distance, which is right there. And then you can see that 6, move this kind of here. This is just kind of the total width of that board right there. This is usually how we lay out our robot from a side, just to kind of give us an idea of how big it's going to be, what the gear ratio is going to look like if we're going to do a 4-wheel drive bot. That's kind of how we set it up. Now you have the holes that you're going to need to punch into the board that supports all this, or the sidewall of your robot. This could come down. This doesn't have to be 4 inches anymore. This could be like probably 2.5. You can see that that's plenty of, meat there for that hole. And you've got good clearances on those holes as well. We could round these once we can chamfer that off and make this a little more sleek in our design if we wanted to. But this gives us a good idea. We're going to finish the sketch. We're going to extrude. This is usually make this out of a 1/4-inch material. I'm going to push it back in the distance so you can see it's going backward, which is good. And then a lot of times I'm going to show that sketch so I can create these holes. So I'm going to use these holes here. And then I'm going to make them so that they are just regular holes, not 1.4 inches. It's going to be 0.2-inch holes. I'm going to switch the direction. They're going back that way. And really they'll have to go 0.25 into the material. They're just going to cut holes in that material. You can turn off that sketch. Again, if you want to at this point, you can do fillets, you can do chamfers. Basically cut these sides down a little bit. So we'll kind of do this. And then I'm going to chamfer these off just to make this look cool. And I've got the... Okay, so this is our backer plate that we've created. Again, hopefully you understand the distances between those. And this should make a lot more sense now that I have the gears ready to go. So I'm going to go back to my gear test, like my main assembly. And this is where I'm going to do my assembly of my parts. So I'm going to joint the gears to this plate. So first joint is going to go, I'm going to do the center one here. And then I need to grab this 36 tooth one here. So I'm going to kind of hover over it and then hold down control, and that should allow me to grab the center point of that. And you can see that it lined it up. We don't want that. We're going to hit flip. So you can see it's on the outside. So you can see this gear is now to the outside. We're going to say okay, but I'm actually not. I'm going to ground this part first. I'm going to right click on it and hit ground. That way, everything that I move is going to move to it. So when I hit joint this time, see how it grays that out? So the first part is going to be selected. So again, hold down control, allows me to grab that center point. It's going to move to this part. And again, I can use the flip tool to flip it around so it's now on the correct side. Let's say okay. And then, so there's my first gear. Second one, joint. Oh, we got to change it to revolute. We'll do that in a minute. It's okay if you don't at the beginning. Again, it's on the wrong side. Flip it. It's not in the front. I'm going to say okay. Then our last one, I'm going to click on this, get the center of that. Again, we're going to have to flip it. So it's on the front and then say okay. So this kind of gives you an idea of where they're going to be at. And you can see the green little lines, that's where their interface is. So that's kind of that's the pitch diameter. You can see the teeth aren't lined up correctly in this case. So we have to rotate them slightly to get them to be in position, in the correct position. But this kind of gives you an idea of what it looks like to start with. First thing we have to do is though change these joints from rigid to revolute. So I'm going to double click on the joint, or you can come back down here and double click on it. We want to edit the joint, and we're going to go to motion and change that to revolute and then say okay. And then we're going to do the same thing for the other two. Change this one to revolute, say okay. Change this one here to revolute. So now they all rotate, but they're not aligned still. So we're going to go back into this one, and I'm just going to put in an angle that I think might work, and then kind of adjust from there. So I'm just going to do 2 degrees and see what happens. So that didn't really change much. So I'm going to go back to here, go to 5 degrees. That didn't get it. Let's go 7. Let's go 12. We're getting closer. 14. Okay, that looks pretty good. See, I've got space now. So I'm okay with that 14 degrees. I might even go 14.5. Nope, too much. 14.2. That looks pretty good. I'm going to go 14.1. 5. That looks good. So now it's going to start in between those teeth. And you can see that because of my backlash number, I've got space between the teeth. Okay, there's going to be a little bit of slop. There needs to be a little bit of room for those teeth to move. So I like that 14.15. That looks good. I'm going to do the same thing on this one. I'm going to just change this. And instead of going 14.5, I'm going to go negative 14.15. Let's see what that does. And you can see that that put that one right in the correct spot on that. And then I'm going to do a motion link to link this revolute and this revolute. So under assemble, there is a motion link. And I'm going to select on this one. So it's my first one. This is my second one. So the first one is going to rotate 2/3 of what this one does. So if this one goes 360 degrees, this one's only going to go 240. And then they should be going in opposite directions. So I'm going to hit reverse. So now you can see that the teeth now match up. So if you kind of zoom out so your eyes don't play tricks on you. And now you can see that as this rotates 360 degrees, this one only rotates 240. So that's my 3:2 ratio. I'm going to say okay. And I'm going to do the exact same thing with the other one. So motion link between this one and this one. And again, this should be 240. It should be 360. And if I hit reverse, those now rotate. We're just looking at these. Don't worry about these right now. Just looking at these right here. These look good. And now all of them should move together. So when I grab one and rotate, you see that they all rotate together the way they should. So as we spin this gear right here, it's going to rotate both of those other gears in our four-wheel drive. That's how we do our gears. We set them up just like this. We test them. We make sure that they work. We can put it on a plate. If we're to laser cut this or use the CNC to cut it out, we could then bolt this all up and we could put them in there and they could spin and it should work just as we designed. So that's how you make gears. Next video, I'll show you how to get it set up for the CNC. Make sure you save your work. Hit save. Everything is good. All right. We'll see you next time. Have a great night.